All right, so I finished typing this up, and so we're going to talk about vector decomposition. And I'll probably sort of switch these two because this is in the next section, but whatever. All right, what I want to do is work backwards, but in a very specific way. So I'm trying to find two vectors that when I add them together, I will get the current vector, but I want to do it in such a way that my two vectors are orthogonal or perpendicular to one another. So working this way, what we have is, I'm going to write this down. So I'm going to find out what V1 is. So vector 1, and I'm given just vector V and vector W. Okay, so I'm going to find vectors of 1. And I find that by taking the dot product of V and W divided by the square of W's magnitude, and then that becomes a scalar. Remember that a dot product is a scalar, so it's a number. And then the magnitude is a number. So this quantity right here is a number, and then I multiply that through to vector W. Okay, so that's what I'm finding. Now, utilizing that, if I am given two vectors, I've got vector V, which is negative 3i minus, oops, sorry, what did I just say? Negative 5i minus 3j, and then I've got vector W, and that is going to be negative I minus j. So remember that there's ones in front of there, okay? And I want to do the vector decomposition. So notice as well that there's a second part to this. So V sub 1, or my first portion of the vector, is going to be found by the dot product divided by the square of the magnitude multiplied through W. The second one just means take your original vector and subtract off the vector we just found. Okay, take your original vector, subtract off the vector that we just found. So we're going to find vector V first. Actually, we know vector V. We're going to find V1 first. So I'm going to do the dot product first. So vector V1 is going to be the dot product between V and W. So again, how do we do dot product? We multiply our horizontal components together and add them to the product of the vertical components. So I've got negative 5 times negative 1 is 5, plus negative 3 times negative 1 is 3. So I end up with 8. Okay? So I have 8. And then I need to get the actual square of the magnitude of W. If you'll remember, the magnitude is the square root of W. Okay? And all the, it's Pythagorean theorem. So if I want to do the magnitude of W, I'm just going to do the square root of negative 1 squared plus negative 1 squared. But remember, I'm squaring this whole thing to follow along with this formula, which means that square root disappears. So for this, I've got negative 1 squared is 1 plus negative 1 squared is 1, which gives me 2. So for this, I just answered it. 8 divided by 2 is 4. So this portion just became a 4. Now I need to multiply it through. So let's just kind of do it because I'm kind of leaving crap empty. So I've got the coefficient. I've got my scalar. Now I need to apply it to W. So for W, I have a 4 times a negative I minus j. And so V1 in this case is going to be a negative 4i and a minus 4j. Okay? That is what V1 is. So I find the scalar and then apply it, multiply it through W. So that's what V1 is. Well, what is V2? V2 is my original vector minus my new vector. So V2 is going to be my original vector minus my new vector. So my original vector is negative 5i minus 3j. Minus my new vector, which is a negative 4i minus 4j. Okay, so distributing, what I've got is a negative 5i minus 3j plus 4i plus 4j. So when we're adding and subtracting vectors together, you're essentially combining like terms. So I've got a negative I And then negative 3 and 4 is going to be a positive, positive j. Okay, so what on God's green earth does this mean? Let's look at our original vectors. So I'm going to take my original vector v, which is negative 5i minus 3j. So negative 5i minus 3j. So here's negative 1, 2, 3. Okay, so my original vector is, pardon my nail file, it doubles as a straight edge. All right, so this is my original vector, v. Okay, and now I want to go ahead and plot vector w. So vector w is negative 1, negative 1. So vector w is negative 1, negative 1. So vector w is just going to be to right here. And what I found is a vector that's going to be it'll be orthogonal to 1. And it will, I found two vectors. One of them is going to be orthogonal to my original vector, and the other one's going to be parallel to my original vector. So for my new and improved, let's go with blue. I've got a negative 4i minus 4j. So a negative 4i minus 4j means that this vector is going to be parallel to my little green vector because they are traveling in the same direction. They are just scalar multiples of one another. Okay, so v is red, w is green, and v1 is blue. So v1 is parallel to w. And now I want to find out what this complement is, and it's a negative I plus j. So let's go to a negative I plus j is going to be right here. So you'll find out that that vector is perpendicular or orthogonal. Let's try and get a little bit closer. Okay, is perpendicular or orthogonal to the green one. So what I did was I decomposed v, and I found a vector that is parallel, okay, and that is orthogonal. Okay, so I decomposed v. So I have the decomposition of v on w. Okay, so we call that the projection of v onto w. Okay, so let's try it one more time. So I'm going to compose two vectors. So I have vector decomposition v is going to be negative I plus 2j. And w is going to be negative I minus j. Okay, so my vector decomposition states that v1 will be the dot product between my vectors divided by the square of the magnitude, and that becomes a scalar, and I distribute that to w. Okay, so dot product first. So I've got a negative 1 times a negative 1 is 1. Okay, so the dot product of v and w is going to be negative 1 times negative 1 plus 2 times negative 1. 2 times negative 1. Okay, so a negative 1 times a negative 1 gives me a 1, and a 1 minus 2 is going to be a negative 1. Okay, so we've got a negative vector, or I'm sorry, a negative scalar, and we're now going to take that through after I divide by the magnitude squared. Okay, so keep going, sorry. All right, so I've got my dot product. Now I need to find the magnitude of w squared. So that's going to be a negative 1 squared plus a negative 1 squared, which gives me the square root of 2, but I need to square it. Okay, so this goes squared, and that goes squared, which means this is 2. So my scalar becomes a negative 1/2. Negative 1/2. So what do I do with that negative 1/2? That's what this thing is. I take that and I multiply it through by w. So negative 1/2 times W means that V1 is a negative half times 1 is 1/2 on I. And then a negative 1/2 times negative 1 is a 1/2 on J. So now I know what those two are. Okay. And so I will now take that and subtract it from my original V to find V2. So V2 is going to be my original V minus V1. So my original V, what is my original V? Negative 1 plus 2. And subtract off what I just found. So 1/2 I plus 1/2 J hat. Okay. All right, so when I subtract this, a negative 1 minus 1/2 is going to be a negative 3/2 on I, and a 2 minus 1/2 is going to be positive 3/2 on J. Okay, so again, this video is going to be a little bit longer simply because we can, actually maybe it's not, I'll probably just do one more. All right, so first of all, let's find a vector. Let me get my notes organized. All right, so we're going to do 3 more problems. One of them is going to be just finding a specific vector with a specific magnitude, and then we are going to find some basic work, and then we'll finish it out in the 3rd video. So what I have is given, I want to find a vector that has a magnitude of 51. Okay, so I want to find this vector. I don't know what it is yet. And I want it to be parallel to 8i minus 15j. So parallel to 8i minus 15j, which means they're moving in the same direction. Okay, they will be scalar multiples of one another. So knowing that, actually let's change this to a u because we're used to starting with v's. Okay, so we'll make this v. All right, so what I have then is I've got some value. I know that this magnitude is 51. I know that if it's going to be parallel, that they're going to be scalar multiples of one another. So what I can do is say that I've got some number, so we'll call it alpha, times v that will give us 51. Okay, so the magnitude of v, so I'm working with v. And then I can take that out and just say, okay, the magnitude of alpha, I'm sorry, the absolute value of alpha, because it's a multiple. The absolute value of alpha times the magnitude of my vector needs to be 51, which means I can start solving for stuff. So to find the magnitude of w, to find the magnitude of v, this is what I've said v is. Okay, so v is this vector right here. So let's find out what his vector is, or sorry, what his magnitude is. Okay, so I know that it's going to be parallel. It's just going to be a multiple. So I just need to find out what the scalar is. Okay, so what this thing's magnitude is going to be the square root of 8 squared plus 15 squared, which is going to be 64. I don't know what this is. 64 plus 225 gives me 289. So I get 17. Okay, so I now know that this thing has a magnitude of 17. So I know what its magnitude is right here. So I've got the absolute value of alpha times 17 will equal 51. Okay, the absolute value of 17, or alpha times 17, will equal 51. It's starting to look like a less than sign. All right, so I can just solve for the absolute value of alpha now. So divide both sides by 17, and the absolute value is going to be 51 over 17, which is 3. So if the absolute value is 3, that means alpha can be either -3 or +3. That is what my alpha is. Okay, so backtrack for a second. This thing's magnitude is 17. I want to find a vector with a magnitude of 51, which is 3 times 17. So if I multiply this by 3, I will have a resultant vector. And we actually have two of them, so you can choose. Okay, so I can choose negative 3 times those will give me a negative 24 on I, and then a plus 45 on J. So that is parallel with a magnitude of 51. Or I can multiply through by positive 3. So that will give me 24 on I, and then minus 45 on J. Okay, and I said we were going to do 2 more problems, but I think that's a great stopping point. So we will finish the last couple of problems in a final video.